Welcome. This video will look at some problems from section 2 of chapter 1 in the Brown SL chemistry book. So question 13 asks you to find the hydrogen atoms in the following compounds. So each of these you're going to use the same process. You're going to set up the molar ratio. You're going to look and see that in this first compound I have 6 moles of hydrogen for every 1 mole of the compound. So that means that 0.02 moles of C2H5OH is going to be 7.2 times 10 to the 22nd moles of hydrogen. And using the same process, or as IB likes to say process, I have 2 moles of hydrogen and 1 mole of H2O. So this is going to become 5 moles of hydrogen. Don't worry too much about sig figs. IB overall will dock you 1 mark for the entire paper 2 for not knowing your sig figs. Just make your best guess at it. I don't think it's worth losing sleep over. And so letter C, 0.1 mole. If I look, I see again I have 2 moles of hydrogen in 1 mole of my HCO3, calcium hydrogen carbonate. And so that's going to give me 1.2 moles of times 10 to the 23rd hydrogen atoms in that. Number 14 is a similar problem. You were told that propane has the formula C3H8, and then you're also told that a sample of propane contains 0.2 moles of carbon. How many moles of hydrogen are present? Well, the formula C3H8 tells you that there are 8 hydrogen for every 3 carbon. So that's the molar ratio I need is 8/3, which when multiplied by 0.02 leaves me with 0.53 moles of hydrogen atoms. Number 15 tells you have 6.02 times 10 to the 23rd atoms of oxygen, and they want to know what would be the amount of sulfuric acid. And amount is generally considered moles unless they specifically say to give mass. So the amount of sulfuric acid, H2SO4, well, the first thing is you should notice that this is really just 1 mole of oxygen atoms, since they picked a nice number or a recognizable number like 6.02 times 10 to the 23rd. So I really have 1 mole of oxygen. So now if I look at my 1 mole of oxygen and I look at H2SO4, there are 4 moles of oxygen in 1 mole of sulfuric acid, or H2SO4. So I set up my molar ratio, 1/4. That means I have just 0.25 moles of sulfuric acid. So number 16, I'm hoping nobody had trouble with, but you're just being asked to find the molar mass of the following compounds. So in part A, you've got 3 magnesium, and you find magnesium mass to be 24.31. Plus 2 phosphorus at 30.97, plus 8 oxygen at 16. So I'm coming up with the molar mass for magnesium phosphate at 262.87, and you can express this grams per mole, or I'll show you the way that IB likes to express it on letter B. So letter B, I've got 6 times 12.01, plus 8 times 1.01, and 6 times 16. Kind of the minimum that IB and I expect you to carry for sig figs with molar masses, you should carry at least to the 100th. If you want to go to the 1000th, that's up to you. But you should be using masses to at least the 100th, otherwise too much air is introduced into your answer. So for C6H8O6, I think this was vitamin C, you end up with a molar mass of 176.14 grams per mole, which again, IB likes to express it as the negative exponent. Whichever one, it all works. You should just be able to recognize it. For C then, calcium 40.08, and there's just the 1, plus the 2 nitrogen at 14.01, and 6 oxygen at 16, gives you a molar mass of 164.10 grams per mole. And then finally, Na2S2O3 with 5 water is going to be the 2Na at 23 plus the 2 sulfur at 3207 plus the 3 oxygen at 16. And now for the water, if you remember, water has a molar mass of 18.02. You could just take 5 times that molar mass. Otherwise, if you don't remember it, 10 hydrogen, 5 more oxygen, and that leaves me with a molar mass of 248.22 grams per mole. In number 17, they want to know how many grams 0.475 moles of calcium arsenate would be. So I've got the 0.475 moles, which means I need to multiply by the molar ratio with grams on top, moles on the bottom. So what I'm really lacking here is my molar ratio. So 3 calcium times 40.08 plus the 2 arsenic times 74.92 plus the 8 oxygen at 16 gives me a molar mass of 398.08. So that's what plugs in up here. And when I multiply that by 0.475, I'm coming up with a mass of 189 or 189.1. We started with just 3 sig figs, so I'd round it to just 189 grams. Number 18 is similar, but this time you have the 66 grams of CO2. You're being asked how many moles it is. So that means the 1 mole goes on top. CO2 12.01 plus the 2 oxygen. This is one we use fairly commonly. 44.01. So 66 grams is going to be right around 1.5, 1.499. So it would round to 1.50 moles. So number 19, I've set up here, you're given 0.50 grams of copper chloride, and you're asked how many moles of chlorine ions that is. So before I can use my molar ratio, I have to change this 0.5 grams into moles. So 0.5 divided by the molar mass of copper chloride, which I came up with 134.55. That's giving me 0.00372 moles of my copper chloride. And then I see that I have 2 chlorine ions for each one. So this is going to be 0.0074 moles (743), I guess if I want to hang on, moles of chlorine ions. Or if you wanted to express this as 7.43 times 10 to the minus third. It's up to you, whichever you're more comfortable with. Number 19, you're told you have 36.55 grams of diamond. They want to know how many carbon atoms there are. So it really doesn't matter what, if it's C6, C12, what the configuration is in diamond, what they consider it to be, because it's all carbon. So I could take the 36.55 grams and divide by 12.01, and that gives me 3.043 or 3.04 moles of carbon. And so if I take that times Avogadro's number, 6.02 times 10 to the 23rd atoms, I end up with 1.83 times 10 to the 24th carbon atoms. Number 21 is a question that they asked you to try and do without the calculator, and these are good practice for paper 1 questions where you don't have a calculator to use. So 0.5 moles of C12H22O11. So how do you do this without a calculator? Well, it's not without calculations, it's without a calculator. And so I only have half a mole, so I'm going to figure out the molar mass of this and divide by half, or divide by 2. So 12 times 12.01, you should be able to pretty quickly estimate that's right around 144. And 22 times 101 is right around 22 for the hydrogen. And it's 11 times 16, which is a little messier, but remember 10 times 16 would be 160, and you just have one more, so this is 176. So fairly quickly then, the 6, the 2, and the 4 is 12. Carry the 1 is 8, 10, 14. Carry the 1 is 342. And if I divide that by 2, I get around 171 grams. Number 22 and number 23 also ask you to complete without a calculator. So which contains the greater number of molecules, 10 grams of H2O or 10 grams of Hg, mercury? And really what they're asking then is which one contains more moles. So 10 grams of H2O, you're going to have to divide by the molar mass of water, which is 18.02, which won't take you too long to figure out. Whereas 10 grams of mercury, you're going to have to divide by the molar mass of mercury, which is 200.59. And even without a calculator, you should be able to figure out that 10 divided by 18 is going to be a much bigger number than 10 divided by 200.59, meaning water is going to have many more molecules in it or particles in it than the mercury. And then number 23, the final one you're supposed to do without a calculator, put the following in descending order of mass. So you have 1 mole of N2H4. So this is approximately 1 mole times 2 nitrogens, about 28, 4 hydrogens. So this is around 32 grams in a mole. That's choice A, or option A that you're supposed to be putting into descending order. And if I do the same thing with the others, 2 moles of N2, so this is about 28 grams per mole. So this is going to be around 56. 3 moles of NH3, so 14, it's going to be around 17 grams per mole. 3 times 17, I know 3 times 15 is 45. 3 times 2, so about 51 grams. And let me just squeeze D on here, 25 moles of H2. H2 is only about 2 grams per mole, so this is around 50. So descending order then should be heaviest to lightest. I should be my 56, or my 2 moles of N2 is first. And then my second mass should be my 3 moles of NH3, and then my 25 moles of H2, and finally my 1 mole of N2H4.